Like its sister General Motors divisions, Buick produced its own family of V8 engines to replace its straight-eight engines. Some of these engines had the same displacement numbers as those from other divisions, but were entirely different engines. Buick Nailhead V8. Buick's first generation of V8 was offered from 1953 through 1956. It was an OHV pushrod engine like the then-new Oldsmobile Rocket V8 engine. This engine became known as the Nailhead for the unusual vertical position of its small-sized valves, which were derisively compared to nails since their head diameter is smaller than other comparable displacement engines of the same era. The Nailhead V8 family used a camshaft with greater lift and duration to offset the smaller-sized valves and arguably restrictive intake and exhaust port diameters. The small diameter intake runners allowed these engines to develop high torque, with many exceeding 1 foot-pound per cubic inch, which was exceptional for the day. All of the Nailhead designs have 4.750 inches bore spacing. Note: the Buick V8 was originally called the nail valve by early hot rodders because the valves looked like nails since the stems were so long and the heads were small. At some point nail valve got replaced by nailhead. 264 The 264 cubic inches 264 was a direct replacement for the 263 straight-eight in Series 40 Buicks. It was produced in 1954 and 1955. It was the smallest displacement nailhead, and the only engine available for the Economy Special Series 40 through 1955. The 264 is a small-bore version of the 322, sharing stroke and deck height. 322 The larger 322 cubic inches 322 was used by Buick from 1953 through 1956 in the Roadmaster, Super and Century models, and finally in the Special in 1956. It had a bore of 4.00 inches and a stroke of 3.20. The 322 was also used in the 1956 through 1959 Chevrolet pickup. Nailhead V8. Buick's second variation of this V8 has also been called the Nailhead. It was produced from 1957 to 1966. 364 The 364 was introduced in 1957. The Special came standard with 2 barrels carb and 250 horsepower, where all others had the 4 barrels, 300 horsepower engine. Buick, like most of its competitors, continued to expand their durable V8 engine to larger displacements, such as the 364 Inacubed X, 3.40 in stroke, equals 364 cubic inches. 400 Your next member of the family was the 401 cubic inches 400. This was actually a 401 that had been later redesignated a 400 to meet GM directives for maximum displacement engines in mid-size cars. Another even later Buick 400 engine was a member of the 400,455 family and was produced from 1967 to 1969. 401 The 401 cubic inches 401 was Buick's full-size and later intermediate muscle car powerplant of choice. This engine was used in the company's Skylark Grand Sport and Buick Wildcat models, among others. The air cleaner for this engine family featured the labels Wildcat 375, Wildcat 410, and Wildcat 445. These monikers indicated not the cubic inch displacement but the foot-pounds of torque produced by the engine. The Wildcat 410 was the 2-barrel carbureted engine that was standard on the 1962-63 LeSabre. The Wildcat 375 was a no-cost option for the 62-63 LeSabre that used a lower compression ratio to run on lower-octane fuel. The 4-barrel version of the 66-67 small-block Buick 340 V8 was also labeled Wildcat 375 on its air cleaner but was not a nailhead engine. The Wildcat 445, with a single 4-barrel carburetor, was the standard engine in the Invicta, 1959-66 Electra, 1962 Euro 66 Buick Wildcat, 1963 Riviera and 1965 Riviera. The Buick 401s were also used as starter motors for the SR-71 Blackbird, mounted on a trolley. In an effort to overcome the restrictive exhaust port design of the Nailhead, Buick drag racing enthusiasts in the 1960s adapted superchargers with a custom camshaft to feed intake air in through the exhaust ports. The larger intake ports became the exhaust outlets. Perhaps this feat of ingenuity, and the unusual appearance of the engine modified in this manner, also intimidated rival racers and contributed to the Nailhead V8 legend in U.S. auto history. 425 the 425 cubic inches 425 was the largest displacement version of the Nailhead. It began as an option in 1963 for the Riviera and was later available on the Wildcat and Electra models. The 1964 and 1966 Riviera used the 425 engine as standard equipment. Full-barrel carburation was standard on all 425 Nailheads, called Wildcat 465. For the 1965 Riviera Grand Sport and the 1966 Wildcat GS, the Super Wildcat regular production option Y48 included two full-barrel carburetors and the intake manifold, which were delivered in the car's trunk, to be installed by the dealer. Toward the end of the 1966 model year, in approximately May 1966, Buick offered the Super Wildcat 465 with dual 4-barrels Carter AFB carburetors as a factory-installed option. This engine is coded MZ, while the dealer-installed dual 4-barrel setup was coded MW. Only 179 1966 Riviera GS cars were built with the MZ factory dual 4-barrel setup, making it a very rare car. Buick's small block. In 1961, Buick unveiled an entirely new small V8 engine with aluminum cylinder heads and cylinder block. Lightweight and powerful, the aluminum V8 also spawned a turbocharged version, the first ever offered in a passenger car. It became the basis of a highly successful cast-iron V6 engine, the Fireball. The all-aluminum V8 engine was dropped after the 1963 model year, but was replaced with very similar cast-iron block aluminum head version for 1 year, and then an all-iron versions. Bore spacing for all variants of the SBB are 4.240 inches. 215 See also Rover V8 engine. GM experimented with aluminum engines starting in the early 1950s. Alco was pushing all automakers to use more aluminum. An early development supercharged version of the 215 cubic inch V8 was used in the 1951 Le Sabre concept car, and the 1953 Buick Roadmaster concept car, and work on a production unit commenced in 1956. Originally intended for 180 cubic inch displacement, Buick was designated by GM as the engine design leader, and decided to begin with a larger, 215 cubic inch size, which was deemed ideal for the new senior compact cars introduced for the 1961 model year. This group of cars was commonly referred to as the BOP Group, a Euro for Buick Olds Pontiac a Euro, or the Y bodies. Known variously as the Fireball and Skylark by Buick, the 215 had a 4.24 in bore spacing, a bore of 3.5 in, and a stroke of 2.8 in, for an actual displacement of 215.5 cubic inches. At the time, the engine was the lightest mass-production V8 in the world, with a dry weight of only 318 pounds. Measuring 28 inches long, 26 inches wide, and 27 in high, it became standard equipment in the 1961 Buick Special. Oldsmobile and Pontiac each used an all-aluminum 215 on its mid-sized cars, the Oldsmobile F85, Cutlass and Jetfire, and Pontiac Tempest and Le Mans. Pontiac used the Buick version of the 215. Oldsmobile had its own. The Oldsmobile version of this engine, although sharing the same basic architecture, had cylinder heads and angled valve covers designed by Oldsmobile engineers to look like a traditional Olds V8 and was produced on a separate assembly line. Among the differences between the Oldsmobile from the Buick versions, it was somewhat heavier, at 350 pounds. The major design differences were in the cylinder heads. Buick used a 5-bolt pattern around each cylinder, where Oldsmobile used a 6-bolt pattern. The 6th bolt was added to the intake manifold side of the head, one extra bolt for each cylinder, meant to alleviate a head warping problem on high compression versions. This meant that Oldsmobile heads would fit on Buick blocks, but not vice versa. Changing the compression ratio on an Oldsmobile 215 required changing the heads, but on a Buick 215, only the pistons, which was less expensive and simpler. For that reason, the more common Buick version has today also emerged as more desirable to some. But the Olds wedge-shaped quench combustion chambers pistons are more compatible with modern low-octane low-lead motor fuels than the Buick hemispherical-shaped combustion chambers and domed pistons. Later Rover versions of the aluminum block and subsequent Buick iron small blocks went to a 4-bolt per cylinder pattern. At introduction, Buick's 215 was rated 150 horsepower at 4,400 RPMs. This was raised soon after introduction to 155 horsepower at 4,600 RPMs. 220 lb-ft of torque was produced at 2,400 RPMs with a Rochester 2GC 2-barrel carburetor and 8.8:1 compression ratio. A mid-year introduction was the Buick Special Skylark version, which had 10.001 compression and a 4-barrel carburetor, raising output to 185 horsepower at 4,800 RPMs and 230 lb-ft at 2,800 RPMs. For 1962, the 4-barrel engine increased the compression ratio to 10.25:1, raising it to 190 horsepower at 4,800 RPMs and 235 lb-ft at 3,000 RPMs. The 2-barrel engine was unchanged. For 1963, the 4-barrel was bumped to 11.1 compression and an even 200 horsepower at 5,000 RPMs and 240 lb-ft at 3,200 RPMs, a respectable 0.93 horsepower per cubic inch. Unfortunately, the great expense of the aluminum engine led to its cancellation after the 1963 model year. The engine had an abnormally high scrap ratio due to hidden block casting porosity problems, which caused serious oil leaks. Another problem was clogged radiators from antifreeze mixtures incompatible with aluminum. It was said that one of the major problems was because the factory had to make extensive use of air gauging to check for casting leaks during the manufacturing process and was unable to detect leaks on blocks that were as much as 95% complete. This raised the cost of complete engines to more than that of a comparable all-cast iron engine. Casting sealing technology was not advanced enough at the time to prevent the high scrap rates. The Buick 215's very high power-to-weight ratio made it immediately interesting for automotive and marine racing. Mickey Thompson entered a stock block Buick 215 powered car in the 1962 Indianapolis 500. From 1946 to 1962, there had not been a single stock block car in this race series. In 1962, the Buick 215 was the only non-Offenhauser-powered entry in the field of 33 cars. Rookie driver Dan Gurney qualified 8th and raced well for 92 laps before retiring with transmission problems. Surplus engine blocks of the Oldsmobile F85 version of this engine formed the basis of the Australian Formula One Refco V8 used by Brabham to win the 1966 Formula One World Championship, although only the earliest engines had any Oldsmobile components. The majority of Refco RB620 engines were cast and built in-house at Refco. Rights to these engines were purchased by the British Rover Company and used in the 1967 Rover P5B that replaced the 3L-6 Rover engine P5. Throughout the years, the Rover Company, which became part of British Leyland in 1968, and its successor companies constantly improved the engine, making it much stronger and reliable. Capacities ranged from 3.5-5.0 L. This engine was used for V8 versions of the MGB GT known as the MGB GT V8. This came straight from the MG works at Abingdon on the Thames. Rover also used the engine in the 1970 Range Rover, which saw the engine successfully returning to the USA after the Range Rover's 1986 introduction. American Buick 215s have also been engine swapped into countless other platforms, especially Chevrolet Vegas and later British cars MG sports cars including the MGR V8 in the 1990s, Triumph Trail 8, and various sports sedans and sports cars by the MG Rover Group and specialist manufacturers such as TVO and the Morgan Motor Company. The engine remains well supported by enthusiast clubs, specialist parts suppliers, and by shops that specialize in conversions and tuning. The 215 was also used in the Italian-American Grand Turismo Apollo in 1962–1963, as well as in the Asado 3500 grams S show car. Although dropped by GM in 1963, the Rover V8 engine remained in production use for more than another 39 years, even longer on the aftermarket. GM tried to buy it back later on, but Rover declined, instead offering to sell engines back to GM. GM refused this offer. In the mid-1980s, hot rodders discovered the 215 could be stretched to as much as 305 cubic inches, using the Buick 300 crankshaft, new cylinder sleeves, and an assortment of non-Buick parts. It could also be fitted with high-compression cylinder heads from the Morgan Plus 8. Using the 5-liter Rover block and crankshaft, a maximum displacement of 317.8 cubic inches is theoretically possible. 300 In 1964, Buick replaced the 215 with an iron block engine of very similar architecture. The new engine had a bore of 3.750 in and a stroke of 3.40 in for a displacement of 300.4 cubic inches. It retained the aluminum cylinder heads, intake manifold, and accessories of the 215 for a dry weight of 405 pounds. The 300 was offered in two-barrel form, with 9.01 compression, making 210 horsepower at 4,600 rpms and 310 lb-ft at 2,400 rpms, and four-barrel form, with 11.01 compression, making 250 horsepower at 4,800 rpms and 335 lb-ft at 3,000 rpms. For 1965, the 300 switched to cast-iron heads, raising dry weight to 467 pounds. Still quite light for a V8 engine of its era. The four-barrel option was cancelled for 1966, and the 300 was replaced entirely by the 350 in 1968. The Apollo 5000 GT sports car used this engine. 340 The 340 cubic inches 340 was a stroke to 3.85 in version of the 300. It had a 2- or 4-barrel carburetor, the 2-barrel with 9:1 compression ratio rated at 220 horsepower at 4,000 rpms and 340 lb-ft at 2,400 rpms, and the 4-barrel with 10.25:1 compression ratio, rated at 260 horsepower at 4,000 rpms and 365 lb-ft at 2,800 rpms. It replaced the 4-barrel 300 for 1966. It was produced only in 1966 and 1967, with the new Buick 350 taking its place after that. 350 Buick adopted the popular 350 cubic inches size with their final family of V8 engines. Although the Buick design shared the displacement of the Chevrolet small block engine family, the Buick blocks were substantially different and of Buick's own proprietary design. The Buick 350 V8 featured the same 3.80-in bore as the 231 cubic inches version of the Buick 90° V6 and retained the 3.85-in stroke of the previous 340 cubic inches V8. It was introduced in 1968 and produced through 1980. The major differences of the Buick 350 in comparison to other GM V8s are Buick's deep skirt engine block construction, the use of cast iron with increased nickel content, the use of an external oil pump, a Ford-mounted distributor, under-square cylinder bore sizing, 3-in crankshaft main journals, and 6.385-in connecting rods. The Buick 350 also shares an integrated aluminum timing cover, which incorporates the oil pump mechanisms as well, leaving the oil filter exposed to oncoming air for added cooling. The engine garnered a reputation as a rugged and durable engine, and some of the design characteristics of the Buick 350 are found in other Buick-designed GM engines such as the 231 cubic inches V6 and its 3800 descendants. Of all the GM 350 cubic inches engines, the Buick 350 has the longest piston stroke. This design characteristic made the Buick 350 significantly wider than the other GM 350s, essentially the same width as the Buick big blocks, which have the shortest stroke of the GM big blocks. At a glance, the Buick 350 can be mistaken for the larger 455 engine. This is due to the oversized intake manifold atop the engine and conventionally angled valve covers that resemble those of the 455. The Buick 350 was used by Kaiser Jeep and AMC Jeep in the Jeep Gladiator and Wagoneer models from 1968 to 71. In these applications, the engine was billed as the Dauntless V8 www.buick.com. Buick Big Block. The company introduced a larger engine family to replace the Nailhead in 1967. This big block design was produced through 1976. As the Buick Big Block V8 was a replacement for the large displacement Nailheads at the end of their production run, it maintains that design's 4.750 inches cylinder bore spacing equals 400 equals. The 399.95 cubic inch 400 was produced from 1967 to 1969. This engine had a bore of 4.04 in and a stroke of 3.90 in. It was the only large V8 engine available for the A-body Buicks due to the GM cubic inch limit restriction prior to 1970. Most parts except the pistons interchange with the 430 and 455. This 400 engine had the distributor towards the front of the engine, as opposed to the 401 that had the distributor back near the firewall. 430 equals. The 429.69 cubic inch 430 was only produced from 1967 until 1969. This engine had a bore of 4.1875 in and a stroke of 3.90 in. The 430-4 engine was rated at 360 horsepower and 475 lb-ft of torque. This engine was used in B, C and E body Buicks. Most parts except the pistons interchange with the 400 and 455. 455 equals. The 455.19 cubic inch 455 Buick V8 used a 4.31 in bore and a 3.90 in stroke. Most parts interchange between the 400 and the 430. It was produced from 1970 to 1976 and was based on the 400/430ths V8. The regular Buick 455 was rated at 350 horsepower, while the 455 Stage 1 was rated at 360 horsepower. The regular 455 produced a rated 510 lb-ft of torque at 2800 rpms, more than any other muscle car engine. The horsepower was somewhat reduced in 1971 mainly due to the reduction in cylinder compression ratio, a change which was mandated by GM in order to cope with the introduction of new federal laws which would require new cars to use low-octane gasoline in an effort to reduce exhaust emissions. Then, starting in 1972, the horsepower rating on paper would be reduced again, down to approximately 250 horsepower, this time due to the new measurement of horsepower as SAE net horsepower, rather than a gross horsepower rating. Unleaded gasoline and catalytic converters came into play in 1975 for all U.S. manufactured cars. Tightening emissions controls would cause the engine to drop in power still further, a little at a time, through 1976. The 455 was one of the first thin-wall casting engine blocks, and because of this advance in production technology it weighs significantly less than other engines of comparable size, less than a Chevrolet 454 and only 25 pounds more than a Chevrolet 350. Other GM V8s powering Buick vehicles. In the mid-1970s, GM was using power plants sourced from various GM divisions where the Buick V8 was considered a factory option with the Buick 350 as the sole survivor, or in the worst case, for Buick vehicles where the 400,455 big blocks were phased out because of fuel economy emission requirements. 260 equals, the 260 cubic inches 260 was an Oldsmobile V8 engine shared with Buick, 1975 1977 Buick Skylark, mid to late 1970s Pontiacs used this motor also. 301 equals, the 301 cubic inches. 301 was a Pontiac V8 engine shared with Buick. 305 the 305 cubic inches was a Chevrolet V8 engine shared with Buick. 1978 Euro 1987 Buick Regal. 1975 Euro 1979 Buick Skylark. 307 the 307 cubic inches was an Oldsmobile V8 engine shared with Buick. 1980 Euro 1985 Buick LeSabre. 1980 Euro 1984 Buick Electra. 1980 Euro 1985 Buick Riviera. 1980 Euro 1990 Buick Estate Wagon. 1986 Euro 1987 Buick Regal. 403 the 403 cubic inches was an Oldsmobile V8 engine shared with Buick. 1977 Buick Century Estate. 1977 Euro 1979 Buick Riviera. 1977 Euro 1979 Buick Electra. 1977 Euro 1979 Buick Estate Wagon. 1977 Euro 1979 Buick LeSabre. See also, Buick Straight 8 engine, Buick V6 engine. From the 1950s-1970s, each GM division had its own V8 engine family. Many were shared among other divisions, but each design is most closely associated with its own division: Cadillac V8 engine, Chevrolet small block engine, Chevrolet big block engine, Oldsmobile V8 engine, Pontiac V8 engine, Holden V8 engine. GM later standardized on the later generations of the Chevrolet design: GM LT engine a Euro Generation 2 small block, GM LS engine a Euro Generation 3/4 small block. List of GM engines. References: Peter C. Sessler. Ultimate American V8 Engine Data Book. Motor Books MBI Publishing Company. ISBN 0-7603-0489-0.